All right, we're going to get started with going over how to do correlations in PSPP. And this is a very straightforward procedure. So I have opened the file titled Correlation Example 1, and I have provided this on Moodle for you to be able to follow along. So what we're going to do, the way I set this up in this hypothetical scenario, is we wanted to see if there's a relationship between how students do on their final exam in chemistry and how students do on their final exam in trigonometry. Because we're assuming, the thought process for chemistry, the type of problem solving you do is pretty similar to the thought process in trigonometry. So maybe doing well in one is going to equate to doing well in the other. If you struggle with one, you're likely to struggle with the other. So let's say this is the study we're doing. So my variables, I have the final score on the chem exam, the final score on the trigonometry exam, and then let's say for these students, we also asked their overall course GPA so far. All right, so what we're going to do is you can either start with a correlation or start with a scatter plot. A lot of people prefer to start with a scatter plot. So we're going to go over here to utilities. No, we're not. We're going to go over here to graphs. Graphs, scatter plot. Click that. Don't know why I put that over there. All right. And we're going to tell it that we want the x-axis to be the chemistry score. We want the y-axis to be the trigonometry score. I'm going to click OK. Mm-hmm. So now we have something that looks like this. Now, remember what we're doing with correlations. We're seeing if it's a linear correlation, can we draw a straight line that would be a pretty good fit for our scores? And just by eyeballing this, it's looking like there's going to be a correlation here, right? Because if I draw, that was not what that was supposed to do. If I were to draw a line up, I'm going to have a lot of dots that are going to be pretty close to that line, right? And it's going to fairly well encompass my data. Now, we can tell just by looking at this plot that there is a bivariate or a multivariate outlier here. Remember, a bivariate or a multivariate outlier is a score that is unusual because of the combination that it has. And we can usually see that if we have a score that is floating off all alone by itself, all right? It's not just a poor fit for our correlation line. It's kind of like over on its own. So if you look at our scatter plot, can you see, before I tell you, which one would probably be the bivariate outlier? It's this guy up here. So what we can see here is the general trend that's happening is as the trigonometry score increases, the chemistry score increases, or the other way, as the chemistry score increases, the trigonometry score increases. So this would be what kind of correlation? It'd be a positive correlation. But we can see over here, we have this one student that failed their chemistry exam, right? It's looking like this score was probably going to end up being like about a 55, 57. It's somewhere between 55 and 60, but got an A+ on their trigonometry test, right? Now, this is not the lowest chemistry score, right? There's a couple other ones that are down here pretty low. It does look like it's the highest trigonometry score, right? This looks higher than this highest one over here, but by no means high enough that it would be a univariate outlier, right? Remember, univariate is strange on one measurement. So it's not a univariate outlier. It is, however, a bivariate outlier because this combination of I failed one test but got an A+ on the other. We're not really seeing that in any other participants. This one down here failed the chemistry test, also failed the trigonometry test. These two looks like they were on the borderline of if they failed or not on the chemistry test. And this one looks like probably D+, C-, and this one looks like probably about failed the trigonometry test. But so this one up here is a bivariate outlier. Now, a univariate outlier, what that would look like would be if this graph was extended further and went all the way to 0, and there was one student like all the way over here who had gotten like an 8% on one of these tests. That would be a univariate outlier, right? Most of these are clustered over here with the lowest scores being in the 50s, and there's this one person that looks like they maybe got one question right and that's it. So that would have been a univariate outlier. So again, one of the benefits of a scatter plot is we can initially get the idea of there's probably going to be a linear correlation, probably going to be a positive correlation. And it looks like we have one bivariate outlier that we're going to need to decide, do we want to leave them in our data set or not? And I'll show you the difference with and without this guy. So let's minimize this. So now we're actually going to compute our correlation. So we go to Analyze, and we go to Bivariate Correlation. I don't know why it keeps putting that all the way over there. Let's get all these back over here. And just like we have with all of our other operations, we click, we want to correlate the chemistry score and the trigonometry score. We'll put the GPA into the equation later. But right now we're looking at the chemistry score and the trigonometry score. We want to do a two-tailed correlation. And you don't have to check this feature, but you actually have a setting where you can flag the significant correlations, meaning you'll just put like a little footnote by it to make it easy for you to see. And that's really all the settings. We don't have anything extra we need to do. We don't have the option of any descriptives. We don't have to do any post hoc tests. Like this is it. So we click OK. Get my output back up here. And now we see this. So what we see is the first line will always be a 1, right? This is called a correlation matrix. The chemistry score had a perfect 1 correlation with the chemistry score, right? But the chemistry score and the trigonometry score, as we predicted, has a positive correlation, an R value of 0.665. Remember what we talked about with the strength of the correlations. A 0.6 would be classified as what? Low, medium, or high? A 0.6 is a high correlation, a strong correlation. And we're significant at the 0.001 level. So within quite a bit of margin of error. So within this particular data set, our one little outlier up here didn't make that much difference, is not throwing our numbers off that much. Now, if you were doing a research study and you had plenty of power to be able to get rid of a couple participants, and you were right on the verge of having a significant correlation, like say you were at 0.052, you didn't quite make it, and you had a couple of outliers, you would want to assess for whether it would be honest to eliminate them. Because we could look at this and we could say a couple of things, right? We could maybe go through, well, actually, let's do that. So we've established we have a correlation and it's positive. So now this is just for fun. Not that you think this is fun, but I do. So also notice this little A it put here. This is flagging your statistical significance. But let's look at this guy. And let's say, all right, let's find this participant that had the super low chemistry score, but the super high trigonometry score. So let's go back over here to our data. Let's look through our scores. And we see him right here, student 581. He got a 58% on his chemistry exam, but a 99% on his trigonometry exam. So let's look at his overall GPA. The student has a 3.9 GPA. So maybe he had a migraine the day of the chemistry exam, but he still went in and tried it. Maybe his dog had died that week and he was upset and hadn't had time to study, but still went in and took the test, but hadn't really studied. So this is something, if this would have come up being on the verge of statistically significant or not, we could probably do some logic, right? And say, this is a student who got an A+ on the trigonometry final that has a 3.9 GPA, so an A+ average GPA overall, but failed this one exam. And so we could probably look at it and say, this student is likely not fully representative of the trend we see going on here. There was probably some strange situation happening there. And so that is a student that we could logic excluding from our analysis if we needed to. It's always best to keep your data intact to allow for those variations that happen, because that's real life, right? There's always weird situations going on. We can't control everything. But if you have something on the verge there, you are able to remove an outlier and be able to have within correlations, it can make a pretty big difference. But when you write up your results of your research findings, you will want to mention that you had a student or two that was a multivariate outlier. Upon further examination of the student's academic record, we realized that there were some grades going on within these classes that were not an adequate representation. There were extenuating circumstances. We removed that student from analysis, right? Like the examples you did when you did your meta-analysis homework. Reading the justifications of the researchers of, this was a good study, but here's why we excluded it. This was a good study, but here's why we excluded it. As a researcher, as a writer, that is one of the things that you explain. You can't just kick them out to make your data fit. But if you have a reasonable explanation for why you do it, you explain it. So, done with that tangent. So now let's say I wanted to go a step further and say, okay, I've seen that the chemistry scores and the trigonometry scores are correlated. Now I want to see if they're correlated with overall GPA. Can I say, how well you do in chemistry has a good relationship to what your overall school GPA will be, or how well you do in trigonometry has a correlation of how well your overall GPA will be. Fun fact, that's why there are so many trigonometry questions on the GRE, the general exam that you take to get into graduate school, the standardized test, but for grad school. That's why there's so many trigonometry questions, because the thought process is, if you know how to study and learn trigonometry, you're good at studying and learning. And so it's a good overall tie to your ability to study and learn new things. So, fun fact for those of you who are planning on taking the GRE and get frustrated about, why am I needing to do all this stuff with all these damn triangles? That's why. That may or may not have been how I felt when I took the GRE. All right, so graphs. Let's start with doing a scatter plot. Compare, and this time what we're going to compare is the trigonometry, not the student number, is the trigonometry exam and the overall GPA. So we want our trigonometry exam to be our x-axis. And we want our overall GPA to be our y-axis. And we're going to click OK. So now we're going to pull this up. All right. This looks quite different, correct? We can still kind of make out a trend that they're moving this way, but this is not near as clean as this one, right? So we're looking at this. There's kind of like a patch going up this way, but it's not as obvious. So this is not extremely clear, but we're still going to run our numbers and see what happens. So analyze bivariate correlation. And you know what, this time I will leave the trig exam or the chem exam in, just so you can see what it looks like when you do a 3x3 correlation matrix. You can correlate as many variables as you want. In the beginning, like if you're actually doing data analysis in the beginning, when you're exploring your data, you can put 15 things in there and have a jumbo correlation and just get a start of, I'm just trying to get a feel for which of my variables are correlated that I need to explore. There are only certain types of research where that is appropriate. Otherwise, it's considered data mining of, I'm just going to run everything and see what happens. But in certain fields, like for example, when I was doing the data analysis with the child abuse agency, that is one thing. Like as we were looking at our counties and we had our numbers and we had all these markers, we're going to throw a bunch of things in this box and we're going to see within this county, are there any markers we can identify that are correlated with the child abuse rate? And is there anything that we can do with those? If you're planning a research study, you want to be careful of that, because again, you can be accused of data mining, of just, I have this data set, I'm going to throw spaghetti at the wall and see what fits, what sticks. So you want to be careful the scenarios that you do that in. All right, so we're going to click OK. So now what we have, this is what a 3x3 correlation matrix looks like. So you can see that what it's doing, let me hide this little bubble. What this is doing is it's telling you, the way you read this is you say, okay, so here's the chemistry exam score. The correlation between chemistry and trigonometry, we already knew this, right? The correlation between chemistry and overall GPA, this is not significant. 0.197, 0.40 with significance. Not anywhere close. Not even kind of. Trigonometry. We already knew it was correlated with chemistry. Come over here to GPA. And it meets statistical significance, but just barely, 0.048. And it's considered a medium strength since it's at 0.4. Well, when you round it, it'd be 0.45. So it is a medium or moderate strength, and it does meet statistical significance. And so that's a good example. If we come back up here to the scatter plot, that is a good example of how just because you can't clearly draw a line, that doesn't mean a line's not there. Because remember, overall what you're evaluating is, if I draw my line, how far are these points from my line? And so this, even though this was a pretty wide group that was kind of trending this direction, it's still enough that we do have a significant correlation there, and one that's considered moderate strength. But I wanted you to see the difference in what it looks like when there's an obvious one and when there's one that, yeah, this could be there, but I still need to run my numbers to see. Oh, and then I told you I was going to show you the difference when we get rid of that one outlier. So keep in mind, our chemistry and trigonometry correlation was 0.665 with that outlier in there. Let's come over here. Where'd he go? And one thing I don't like about PSPP is in SPSS, you can keep a case and just like deselect it for that analysis. You can't do that in PSPP. You actually have to clear it out. So let's here. So we've cleared him. Let's go back to correlation. Let's do chemistry and trigonometry. Click OK. So we were at 0.665, and now we're at 0.894. So we got a pretty big jump in our correlation coefficient, just removing that one outlier. So you can see how if you were on the verge of being statistically significant, you would want to evaluate, can I justify removing my outliers? Because it could make the difference between a significant and a non-significant result. So that is the first example of correlations. And now we're going to pull up another data set for the second video, and I'm going to show you an example of what, actually we can pull it up on the same video, and I'll show you a quick example of what a curvilinear correlation looks like. So let me open, here, before I do this, put this guy back in here. There we go. I don't want to, all right. Oh, let me undo. All right, well, this is a problem for a later time to get our one outlier back. Okay, so let's go to File, Open, Correlation Example 2. So in this one, I went back to the exercise and well-being example that we talked about in the lecture video. Let's say we were going to analyze and do a correlation, and I want to correlate our exercise hours with our well-being score. I'm going to click OK. And remember, your output will keep everything unless you clear it. So I didn't exit out between the two examples. That's why you're still seeing all this nonsense. So what we see here, exercise hours, well-being. I do not have a statistically significant correlation. Not even close. My significance is 0.388. Not on the verge, I have an outlier I need to get rid of. Nada. But let's see what's actually going on with these numbers. So come to graph, come to scatter plot. Let's say our exercise hours are our x-axis and our well-being score is our y-axis. Let's come back over here. Okay, so as your textbook stated, what we have here is a curvilinear correlation. And not one of the ones that's kind of humping that, that was a weird way to say that. Not one of the ones that has the waves in the line, right? That we could do the Spearman's row, which unfortunately PSPP does not do Spearman's row. You'd have to do a command to rank the cases and then do your correlation. Separate point. But this is not one of those. This is one that's going up and then down, which remember we talked about Spearman's row, cannot do those either. So if we were wanting to actually do a correlation of this, what we would need to do would be to split these. And we would need to look at, okay, so for participants who exercise 0 to 2.5 hours, we see this trend. For participants who exercise from 3 to 7 hours, we see this trend. And we would split them. But I just wanted you to see, like, if you were to pull up a scatter plot that looked like this, I wanted you to see what that curvilinear correlation would look like. So that is correlations in PSPP. Pretty simple compared to some of the other statistical processes that we've covered using the software. If you have any questions, definitely feel free to give me an email and we can work through them.